Hello and welcome to lesson 10 of module 6. By the end of this lesson, you'll be able to identify situations where it's reasonable to use a linear function to model a relationship between two variables. You'll know you're successful when you can interpret slope and the initial value, y-intercept, of data in context. So basically, we're just going to be reading situations and writing equations for them. Okay? Let's go ahead and get started. All right, the first thing we want to do is to just build some background around independent and dependent variables. So we're going to talk about possible dependent variables when given an independent variable and possible independent variables when given a dependent variable. One thing I do want you to write on this page, at the very top before we start filling in this table, is that x is always independent, sorry. It comes first. And y is always dependent. Another way to look at this is cause and effect. Right? Sometimes you're given the effect and you have to think of what would the cause be. Sometimes you're given the cause and you have to think what would the effect be. So for exercise 1 right here, we are going to identify two possible independent variables that might explain this. So what might explain, we're looking for x variables, the height of a sun? Well, what would be the cause of the height of a sun? What causes our height? Well, maybe the mother's height. Okay, and maybe the father's height. These are two causes or two independent variables that influence the height of a sun. Okay? Number 2, or row 2. The number of points scored in a game by a basketball player. What might influence that? What might be the cause of that? Well, I would say the height of a basketball player. That's one thing that influences that. Usually the taller a player is, the more baskets they can score. And then maybe the age of the player. If you're watching like young kids play basketball, like second graders, they're probably not going to score many baskets, right, when they're playing a game. If you're watching, sophomores in high school play basketball, they're probably going to score more baskets, okay? Next one, the number of hamburgers to make for a family picnic. What determines that? Well, I would say the number of people in the family, right? That causes you to figure out how many burgers you're going to make. And another thing that might influence this is the price of the burgers. Okay. Next, the time it takes a person to run a mile. I would say something that definitely influences this is the age, right? Older people tend to not be able to run as fast, and little kids might get distracted when they're running. It's the age of the runner. Something else that might influence the time it takes a person to run a mile, maybe where they're running, the location of the run. If you're running up a mountain, it's going to affect your time, right? If you're running on flat lands, it's going to affect your time. Last one here, amount of money won by a contestant on Jeopardy. So the amount of money won by a contestant on Jeopardy, I would say their intelligence. Maybe their IQ. Right? Usually the smarter you are on Jeopardy, the more money you can win. And I would also say their quickness. I don't know know if you guys have ever watched Jeopardy, but if you hit the buzzer first, you get to answer first. So the quicker the person is, maybe the more money they'd be able to win. So here we've just identified some possible independent variables that would explain these responses. Okay, I'm going to have you do more of this on the next slide, kind of trying it out with me in the chat. Okay, let's continue on. All right, so I want us to continue this. Again, we're looking for independent reasons to explain these dependent responses. Okay, so first one, fuel efficiency for a car. What might affect that? Please come up with something in the chat for me and post it publicly so I can look at the responses and put something down here. Okay, for number 2, number of honeybees in a beehive at a particular time. What might affect that? Please write something in the chat for me. Number 3, number of blooms on a dahlia plant. So just think of a plant. I don't know if you know what that is, a dahlia plant, but just think of any plant. Number of blooms, the number of like flowers it has. What affects that? What's a reason for that? And then the last one here, the number of forest fires in a state during a particular year. What would be a reason for that, or a possible explanation? All right, let's continue on. All right, we're going to do this one together as well. One thing I really hate about the way they set this up, they put these in the wrong column. I do not know why they have the y value over here and the x value over here, and I apologize for that. But now we're going to be coming up with things that depend on these independent variables they give us. So I'm going to do a few, and then I'm going to have you guys fill out the rest, and we'll share out, okay? So the age of a student. What depends on the age of the student? Well, I would say something that depends on the age of someone is how smart they are, right? And maybe how tall they are. You only have to write one. I'm just coming up with a few. All right, height of a golfer. What is something that depends on the height of the golfer? Well, I don't know much about golf, but definitely the height of their clubs. I know that like you buy clubs that are specific to your height, right? I can't really think of anything else there, so that's all I'm going to put. I'm going to do one more with you, and then you're going to do the rest. Amount of pain reliever taken. So I would say here that how you feel. I'm just going to put how you feel pain. Take more pain reliever, you're going to feel less pain. Okay? So I want you to go through, and I want you to do these last 4. Put something in there. And then we will move on to the next slide in about 2 minutes, okay? And we'll share out some of our responses in the chat. All right, now that we have gone over independent and dependent variables, it'll be easier for us to identify them when we're writing our equations today. So this first situation they give us says, a cell phone company offers the following basic cell phone plan to its customers. A customer pays a monthly fee of $40. In addition, the customer pays 15 cents per text message sent from the phone. There's no limit to the number of text messages per month that could be sent, and there is no charge for receiving the text messages. So a few things I want to identify here. There's a monthly fee of $40. And in addition, I'm going to be using an addition sign to that, the customer pays 15 cents per text message sent. Okay, so I'm going to be writing an equation here, and I need to figure out what is going to be my x value, what is going to be my y value. Okay? But first, I'm just going to answer some of these questions that they give me because they'll kind of help lead my thinking. So it says, Justin never sends a text message. What would he pay that month? What would be his monthly cost? So if he never sends a text message, he's never paying that 15 cents for each one, but he is still paying his monthly fee. So he's still going to be paying $40. Okay, that is the initial value he has to pay no matter what. B, it says during a typical month, Abby sends 25 text messages. What's her total cost for a typical month? So Abby's going to pay that $40 up front, right? Plus, she's going to send 25 text messages, and each one of those costs 15 cents. So I'm going to be doing 15 cents times 25. Okay, and we can figure that out pretty quickly. Just do it in our calculator. 0.15 times 25 equals $3.75. So now I'm doing $40 plus $3.75. So her total monthly cost is going to be $43.75. Okay. Robert sends at least 250 text messages a month. What will be an estimate of his monthly cost? So he's going to have that $40 up front, right? Plus, he's going to be spending 15 cents for every text message, and he's going to be doing that 250 times. Okay, so I'm going to quickly do this math. 250 times $3.75, this becomes $37.50. And we're adding that to our 40 for the monthly cost. And we get a total of $77.50. Okay? Now, whether you identify this or not, we were using an equation, and we were using an equation that we can write in slope-intercept form. We will talk more about this in just a moment. So please make sure you have this down before we move on to the next slide. All right, so we're really going to dive into breaking down how to write this equation. And we're going to start off with number 4 by writing out a sentence, basically. So what is going on here? Well, we're finding the total monthly cost. And this total monthly cost is, it's going to be dependent on how many text messages they send. Okay? So the total monthly cost is dependent on the number of texts sent. One thing I want to add here is that you pay 15 cents for each message plus an initial cost or initial fee of $40. All right. So both of those things are really important. Those two sentences I just wrote, they're going to help me create my equation in just a second. And a few words I want to point out are dependent. This one for each message, my plus, and then this initial word. Those are going to give me clues as to what the numbers, or where the numbers go in my equation. It says, is the relationship between the number of text messages sent and the total monthly cost linear? Well, we've talked about this a lot, but I just want to reiterate it. Yes, this is linear. And the reason it's linear is because none of our variables have exponents. Number 6, it says let x represent the independent variable and y represent the dependent variable. Use the variables to write the function regarding this relationship. So we are writing our equation in y equals mx plus b format. We're going to use those keywords up there to help us out. So the first thing that I wrote is that the total monthly cost is dependent. So the total monthly cost is dependent. Remember that our dependent variable is our y variable, right? So our total cost is our y, okay? And it's dependent on the number of texts sent. That means this is our x. So I'm just going to leave these as y and x, but now I know what they represent, okay? From there, I can do a few things. So the number of texts sent. So our x, you pay 15 cents for each of those x's. So what's going to go right beside that that x? My 15 cents. Okay? So this now becomes y equals 0.15 times x. And then it says plus, here we have our plus sign, an initial fee. Remember our initial value, that's our y-intercept. So this initial value is $40. So this would be my total final equation. I'm going to write it in green over here to the left so it's just a little bit bigger. Y equals 0.15x plus 40. All right? Below it just wants us to be a little bit more detailed with our description of these things. It says, explain what 15 cents represents. 15 cents represents the slope, right? That's in our M position. Okay? And explain what $40 represents in this situation. $40 represents our y-intercept. Or we call that our b value. Okay, y equals mx plus b. Our m is 15 cents, our b is $40. Okay, please make sure you have this down and we will continue on. I was going to have you guys graph this relationship, y equals 0.15x plus 40, but I'm actually going to do it with you just for the sake of time. So we want to start with our initial value at 40. This is our y-intercept, so we go to our y-axis. This is our x-axis, and we're going to be starting at 40. So this is where we are starting right here. Okay. From there, our slope is 0.15. So we're going to be going up 15 cents over 1, up 15 cents over 1. But if you look down here, for our x-axis, our intervals are not in increments of 1. So what we're going to do is we're going to have to apply our equation to find where is our dot going to go when it crosses this 25 line. So this 25 is our x. So I'm going to be changing this x to a 25 to figure it out. So y equals 0.15 times 25 plus 40. We'll do this really quick to find out where this line is going to fall. So 0.15 times 25 is $3.75 plus 40. When we do that, we get $43.75. So when we are at 25 on our x, we are at $43.75 on our y. So we're going to be right around here. Okay? I'm going to do a few more points. Let's do 100. So when we have 0.15 for our rate, we're going to be timing that by 100 because we're doing 100 text messages and we're doing plus 40. 0.15 times 100 is just 15. 15 plus 40 is 65. sorry, 55. So this 100 is going to be crossing at the 55 mark. Right there. And let's just do one more. I'll actually have you do one more for me. I want you to do 250. So please find this one by solving this equation, 0.15 times 250. And message me in the chat where you get your point. All right, you should have found that at 250 text messages, this person is going to pay $77.50. So this is pretty close to this 80 mark. Okay. And there we can connect our lines. And that's our graph. This is obviously a positive linear relationship. The more text messages you send, the more you're going to pay. And it's a constant rate because our rate's never going to change. It's not going to say, oh, well, after 30 text messages, you only pay 10 cents, because that's not how this plan works. Okay? Let's go ahead and move on. We're going to get into some practice for you guys. All right, here you're going to start to try this out a little bit. We have a new situation. It says, Lemoyne needs 4 more pieces of lumber for his scout project. The pieces can be cut from one large piece of lumber according to the following pattern. So you can see those little cuts there. He's going to need to make 3 cuts. The lumberyard will make the cuts for him at a fixed cost of $2.25 plus an additional cost of 25 cents per cut. One cut is free. Okay. What is the functional relationship between the total cost of cutting a piece of lumber and the number of cuts required? What is the equation of this function? All right. So what you're going to do right here is define the variables. So I'm going to help you out just a little bit. You always want to start with the monthly cost or the total cost. Depends on, and I want you to finish that sentence. So depends on what? Okay? I'll give you a second to do that. All right. So you should have identified that the total cost depends on the number of cuts. Okay? We want to go a little bit deeper than this and kind of write a little bit more about the numbers that they give us. So the cost for cutting is going to be 25 cents per cut. Plus an initial fee of, I want you to please write that in. What is the initial fee? All right, you should have identified that the initial fee is $2.25. But there's one extra part here that we have to include. It says that one cut is free. So because of that, I'm going to have to rewrite this a little bit differently down here. So I'm going to rewrite it and say the total cost for cutting equals, well, we have $2.25, our initial fee, right? Plus 25 cents times our number of cuts, but we don't know how many cuts there are, so that's our X variable. But one cut is free, so I'm taking away one because we don't have to pay for one of those. So this is the final kind of situation I've come up with. Remember that this is our dependent variable. This is our initial value. This is our rate. And this is our dependent variable. Okay? We're going to continue on with the next part of this on the next page. All right, here you're going to actually use the equation we came up with to determine the total cost for cutting. So the equation actually was, please write this down, y equals our slope or our constant rate, was 0.25 times x minus 1 plus the initial fee of $2.25. Okay, now if you think back to the last page, there are 3 cuts that he's making. So you're going to be turning this x into a 3, and I want you to solve this problem. I'll give you about 1 minute to do that. Alright, you can see that I've filled in my work here. The first thing I did was plug in my 3 for the x value. I then did 3 take away 1, I got 2. Then I did 25 cents times 2, I got 50 cents. The last step is going to be doing 50 cents plus $2.25. This total price comes out to $2.75. Total cost equals $2.75. Okay? Next one, it says, in the context of the problem, interpret the slope in words. So what is the slope of this? Well, look at your in position. It's this value right here, highlighted up here in yellow, and explain to me what that means. I'll give you a second to do that. What does that 0.25 actually mean in the context of this problem? All right, you'll see what I've written down here. Basically, that slope means that after the first free cut, you're going to pay 25 cents for every other cut. Okay? Now I want you to interpret the y-intercept of the problem in words. So the y-intercept was this value right here, $2.25. What does that represent here? Go ahead and explain that in words down below. All right, I went ahead and I wrote that you pay an initial fee of $2.25 to have the wood cut. That is what that $2.25 represents here. Okay? Now, one thing I do want you to think of is, what if you didn't have to cut the wood? Would you still have to pay $2.25? No, you wouldn't even be coming to this place, right? So some things, like the cell phone plan, you would still have to pay $40 even if you didn't send a text message. But if you didn't make a cut on this wood, you wouldn't have to pay them anything, right? Because you only have to pay that $2.25 if you're using their services. Okay? Let's go ahead and move to the next slide for number 11. Alright, I actually decided not to do number 11 with you because it was pretty lengthy and it just was the same thing we've already been doing. So we're just going to summarize the lesson today. It says a linear functional relationship between a dependent and independent numerical variable has the form y equals mx plus b. In statistics, a dependent variable is the one that is predicted. An independent variable is the one that is used to make the prediction. The graph of a linear function between two variables is a line. Let's talk about what you're going to be doing for your exit ticket today. Alright, here are the things you will need to be doing for your exit ticket. The first thing you're going to do is you're going to identify the independent variable in a given situation. Then you're going to identify the dependent variable. You will identify the slope. You will identify the y-intercept. And you're going to take all of those and you are going to write an equation. Alright, we should be able to do this pretty quickly and easily. I'm going to give you 10 minutes and then we're going to go over it. If you finish before the 10 minutes is up, please work on your lesson reflection for today, any missing work, and please remember that Monday's work is due today as well as your homework for Moby Max. Go ahead and get started, please.